24 is 9 minus 4i over 5i. Now remember, we cannot have a radical in the denominator. And remember, I is a radical. It's the square root of -1. So we have to get the I out of the denominator. So I'm going to multiply the top and the bottom by the same thing, just like we did. I don't remember what number it was. It was that square root of 11 over 2. Remember we had to multiply the top and the bottom by square root of 2? So I'm going to multiply the top and the bottom by the same thing. Now, the 5 is fine. I can have a 5 on the bottom. It's the I can't have. So I'm going to multiply the top and the bottom by I. You can multiply the top and the bottom by 5i if you want. It's just, then you're going to have some simplifying and some reducing and some extra steps at the end. So this is going to give me, now I'm going to have to distribute because that is a group. So I actually have to distribute I throughout my numerator. So that's going to give me 9i and a minus 4i squared over 5i squared. And now out of 9i minus 4i squared over 5i squared, what can I simplify? The I squareds. I can change all of my I squareds to -1. So I really have 9i plus 4 over -5. -4 times -1 is positive 4, yeah. So now, technically, I mean, I'm done. There's no I in the denominator. There's no radical. Nothing can be factored out. I mean, it's pretty much done. Except when you read the how they want you to put your answer in, it says, simplify your answer, type an integer or a fraction, type your answer in the form a plus bi. In other words, we're not in the proper format. So in order to put it in the proper format, I need to take it out of one kind of weird looking fraction and rewrite it into two separate fractions. So I have an a fraction and I have a bi fraction. So that's what they're talking about, a plus bi form. So that just means that both parts of my numerator get that division of -5. So we could say 9 over -5i, and then we could say, well, instead of doing that, we could actually say plus 4 over -5. So now I have two distinct terms instead of one kind of yucky fraction. And I'm almost right because they want a plus bi form, which means they want that I term to be last. So a plus bi form, I put my number first, which in this case would be 4 over -5, and then I put my number with the I attached to it after that. And I just kind of float my I there in the middle. You can put the I up with the 9 if you want, but when you enter it into my math lab, make sure you do like a fraction and then a fraction and then click out of the fraction and then put the I. Don't put the I in the denominator, which is what some students accidentally do, because that would be wrong. So this is a plus bi form. Now, put it in your calculator. Make sure your numerator, surround it with parentheses. So make sure you do your original problem in parentheses 9 minus 4i, and then divide by 5i. You're going to get something that looks a little weird because it's going to give it to you in decimal form. But how do you change it from decimal to fraction? Do a math enter, and then you should end up with, did you get it? Did you put the numerator in parentheses? Did you get it? Yeah. Yay! So we have 5 plus 4i all over 4 plus I. Okay, so this one, our denominator looks a little bit different. It's actually a binomial instead of just the monomial, like the 5i. It's 4 plus I. We didn't have a plus or a minus in the last one. Not in the denominator anyway. So the way we treat it, we have to do it a little bit differently. We're still going to multiply the top and the bottom by the same thing. But this time we're going to multiply by something called the conjugate. And you'll see why we do this here in a second, when I actually do the math. Now remember, these are groups. So I actually have 2 FOIL problems here. I have to FOIL the top, and I have to FOIL the bottom. So I'm going to have 4 terms on the top, and I'm going to have 4 terms on the bottom, and I'm going to try to simplify if I can. So I actually want to start with the denominator because I want to show you why we multiply by the conjugate. Why do we change the sign? So let's FOIL the bottom first. So first terms, 4 times 4, 16. Outer terms, we have 4 times negative I, so that's negative 4i. My inner terms would be a positive 4i. And my last term would be negative I squared. The reason why we multiply by the conjugate is because then these terms cancel each other out. And I no longer have an I in the denominator because I squared is a number. We'll simplify that here in a minute. So now I is no longer in my denominator. Had I multiplied by the same exact denominator, 4 plus I, and multiplied by 4 plus I, my i's wouldn't have canceled. I still would have had an I because I would have had plus 4i plus 4i. So that's why we multiply by the conjugate. So I'm going to go ahead and FOIL the top real quick. So here 5 times 4 is 20. Let's see, it would be negative 5i plus 16i minus 4i squared. I think. Does anybody agree, disagree with that? Tell me now. Okay, thank you. So now let's go through and simplify what we can. So in my numerator, I have like terms, my 2 middle terms, minus 5i plus 16i. So that's going to be plus 11i minus 4. And I'm going to go ahead and replace my I squared right now. Might as well. And I have 16 minus I squared, so minus negative 1. So I want to make sure everybody's okay up to this point before we move forward. Let's see here, 20, and then that would be a minus 4 times minus 1, so that's actually a positive 4, right? So that means I really have 20 and 4, so I really have 24. So I am kind of skipping a step there. Plus 11i over, that would be 17 on the bottom. So now we're pretty much done. We just have to put it in a plus bi form. So that's going to be 24 over 17.
A plus bi form.
Plus 11/17. I'm going to double check that. Yep, that's right. And if you put that in your calculator, you'll get the right answer too. Okay, so number 13 is very similar to the one that we just worked. Now, it doesn't have an I in it, but it does have a radical. So it works the same way. Because remember, I is a radical. So we still have to multiply by the conjugate.
What's a conjugate?
Same terms, opposite signs. Now, this one is a little bit easier because my numerator is just a single number. So I don't have to FOIL the top like I do the bottom. I just have to distribute. So that's going to make it a little bit simpler to work with. However, in my first step, I just leave it factored. I don't multiply until the end, and I'll explain why that is once I get there. So I'm just going to leave this as 8 times 4 plus square root 3 over. Now, what you should have learned from the last problem was we multiply by the conjugate so that our two middle terms cancel, which means out of the FOIL process, the outers and the inners go away. So all that's left is your first and your last. So you can actually just do the first and the last. You don't have to do the outers and the inners because you know they're going to cancel anyway. But that's up to you. So all I'm going to focus on is my first terms, which is 4 times 4, which is 16. And my last terms, which would be negative, because one's a positive, one's a negative, square root of 3 times square root of 3, which is square root 9. My outers and inners would just end up being opposites and canceling out anyway, so I'm not even going to worry about them. If you want to do all 4 terms of FOIL, you can. So now that's going to leave me, I'm still going to leave the top factored. And on the bottom, I'm going to have 16 minus the square root of 9 is actually 3. So now 8 times 4 plus square root 3 all over 13. Now this is not an I problem, so you don't have to worry about A plus BI form. I think my math lab will actually take this as a final answer. The reason why I left the top factored is because had the denominator ended up being like 14 or 16 or 20, I could have simplified. I could have reduced like a 2 out of an 8 and a 2 out of a denominator. And it's easier to do if you just leave it in factored form. So because 8 and 13, I can't simplify that. There's nothing else I can do here. I don't have to put it in a certain form. I believe my math lab will take this form. Or if you distribute the 8 and actually get, 32 plus 8 square root 3 over 13, it should take either one. And you don't even have to split it into 2 fractions like we have to with the i's. Okay?
I have a question. How do you get, negative root of 9?
I did negative square root 3 times positive square root 3. So a negative times a positive is a negative. And square root of 3 times square root of 3 is square root 9.
Okay.
And then square root 9 ends up being just plain old 3. Okay. So any questions on that one? The ones that don't have I actually have a little bit less work because you don't have to worry about the certain form. Alright, so now the only one we have left, I believe, with the radicals is the equation, which is number 7. Which is, So on this one, whenever you're dealing with radicals in an equation, we need to get rid of the radical. Most of the ones that you were doing in the homework assignment, if you've already done this homework assignment, is get the radical by itself and then do the opposite operation. How do you get rid of a square root? Well, you square it. And remember, what you do to one side, you have to do to the other side. So if I square both sides, I'm left with 8y plus 1 equals 7y plus 12, because the square and the square root cancel each other out. So really I'm just left with a multi-step equation that we've been solving forever in here. So square both sides, the radicals go away, and now I can just start moving terms around. I'm just going to subtract 7y from both sides. That's going to give me y plus 1 equals 12. Subtract 1. And that leaves me y equals 11. Yeah. The only thing you have to remember is just whenever you've got a radical in an equation is just to square it.